Yeah. Now we are learning about functions and their graphs. And then this is the first part. So for the first hour, we will learn about function and their graph. And then for the second hour, we will learn about combining function, shifting, and scaling the graphs. Materials. What are the materials for today? We will learn about function, domain, and range, and then the graph of those functions, and the definition of increasing and decreasing functions, and the definition of even and odd functions, and their relation to symmetry. And then we learn for the part 2 later about combining function and how we can shift and scale and reflect graph of a function. So first part is what is a function. This is the formal definition of a function, which actually you don't really need to remember this definition. But if you are asked about the definition, the formal definition of a function, it should look like this. So a function f from a set D to a set Y is a rule that assigns a unique element fx in Y to each element x in D. This is the formal definition. Basically, we have a function. Normally, the function will look like this. For example, here, y is a function of x. We can write it like this. Y equals f of x means that y is a function of x. In this case, x is called independent variable because we can, even though x is a variable, we can change its value. We can change its value, and it doesn't dependent on any other values. So we can vary the value of x, but y is called dependent variable because the value of y is dependent on the value of x. So whenever we change the value of x, the value of y will follow. So from this definition, we have that this set D, so basically x is in the set D, and this set D must be the set where the function f is defined, is well defined. In that case, the set D is called the domain of the function, and the set of all outputs as x varies through D is called the range of the function. In this case, the range is the set y, basically the subset of y. For example, we have a function y equals to x squared. What is the domain of this function? The domain of this function is from minus infinity to positive infinity. So basically, the domain of this function is all real numbers. Why? Because x squared is defined over all the real numbers. But for the range, if we plug any values from here, so if we change the values of x over this domain, the values of y will vary, will change from 0 to positive infinity. So in this case, why the negative value is not part of the range of this function is because the value of x squared cannot be negative, and yeah, and since the domain of x is all real numbers, then we have non-negative numbers as the range of this function. But what happens if we have different function that let's call it 1 over x, y equals to 1 over x. 1 over x is defined if the denominator is not equal to 0. So meaning that in this case, as long as x is not equal to 0, then we have the function y equal to 1 over x well defined. We can so basically, as long as x is not 0, we can have the value of y. So in that case, the domain is now all real numbers except 0. How to know that 0 is not included? You can see here that we have from minus infinity to 0, but 0 is not included because we use normal closed bracket. And the next set is from 0 to infinity, but 0 is also not included because the open bracket is the normal bracket. In this case, okay, let's take negative x. If we take negative x, the value of y is always negative. And the smaller x, the value is closer to negative infinity. And when the value of x is closer to, if the value of x is going to negative infinity, then we have the value of y getting closer to 0, but it will never be 0. Because you see here that the denominator is not 0, that's why it cannot be 0. And if we change to this side of set, to the positive set, when we move to the positive domain, whenever x is closer to 0, the value of 1 over x is getting closer to positive infinity. And when the value of x is going to infinity, going to positive infinity, the value of y equals to 1 over x is getting closer to 0. That's why now the range is like this. So can anyone here explain to me why the domain of y equals to square root of x is only non-negative number? Can anyone here explain to me what is the reason behind this choice of domain? Hello. Anyone? Or any question? Please let me know if you don't understand anything. Come on. Don't be shy. Okay. Let me choose one. Jason Lim, can you explain to me why the domain is non-negative numbers?
Wait, sir.
You can, if you are not, how to say, if you're not confident with explaining it in English, you can also explain it in Bahasa.
Oh, it's okay, sir. Why there's no negative number? Because, in my opinion, a negative number cannot be root.
Yes.
Nggak bisa diangkat.
Correct. Yeah, that's because in this case, if we put negative number inside the square root, then we don't have a real value of y. Well, actually, we will have like a complex value, imaginary value. But in this case, we cannot, I mean, this function is not a real valued function. So in this case, the domain is just 0 to infinity. That's correct, Jason. And the range for this function is from 0 to infinity, and 0 is included. What about the second part? Sorry, the fourth example. We have y equals to square root of 4 minus x. In this case, we want all the thing inside the square root to be non-negative. That's why we must have something like this. So y equals to square root of 4 minus x. So in this case, what we want is what is inside must be less than or greater than or equal to 0, meaning that we have 4 minus x greater than or equal to 0, or we will have x less than or equal to 4. So this function is defined if x, this real valued function is defined if x is less than or equal to 4. That's why the domain is now from minus infinity to 4. But the range remains the same. The range is from 0 to positive infinity. Anyone knows why? Let me see. Vidya. That's Vidya.
Yes, sir.
Yeah. Can you explain to everyone here that why the range is from 0 to infinity? Again, if you're not confident, you can explain to us in Bahasa.
I still don't know, sir.
Okay.
Can I help her?
Yes. Jason,
Oh.
okay.
Right. So why the range is 0 to infinite? That's the question, right?
Yes.
So first, because the function, maybe I think, because the function is 4 minus x di akar. Ya.
Yes.
Walaupun dikurangin dengan bilangan negatif, hasilnya akan tetap positif. Dan di domainnya kan ditulis min infinite, itu bacanya gimana ya? Min infinite sampai 4 ya, atau dan 4?
Yeah. Minus infinite to 4, yes.
Ya, that's why the domain only cuma sampai 4, karena kalau 4 kurang 4, akar 0, dan akar 0 itu masih termasuk di dalam range-nya. Ya, karena kurungnya gitu. Ya.
Yeah.
That's all, sir.
Yeah. Good explanation, but let me start from this function. Where is my okay? Y equals to square root of x. The domain of the domain here is from the domain is from 0 to infinity. As long as it is the x is not negative, then we have this function is defined. Then the range, let's see. So basically, to check the range, is we try to change x from 0 to infinity. Okay, x equal to 0, meaning that the square root of 0 is 0. So we have 0, and then we increase the x 0.1, 0.2, 0.3, and so on and so forth until infinity. As the x increases, the value of the square root of x also increase. Then, okay, let's say the square root of 10,000. What is the square root of 10,000?
100.
100. And if we increase the value of x until infinity, then what is the square root of infinity? Maybe it's better if I explain it with the graph. So we have x, y in the positive on the first quadrant. The value of y when x is equal to 0 is 0. And then if we increase, it will increase like this. It will always increase like this. So let's say this is the graph of y equals to square root of x. So we see that whenever x increases, y also increases. That's why when x goes to infinity, the value of y is also going to infinity. So the value of y also goes to infinity. That's why we have the range to be from 0 to infinity. Now, what happened with this guy? With this guy, let's say we introduce a new variable. Let's call it r equals to 4 minus, 4 minus x. Then we have y equals to square root of r. So in this case, if x is in minus infinity to 4, what will the value of r be? So in this case, what is the value of r? What is the range? What is the interval for r in this case? So we take a look at this. If we take x equal to 4, r is 0, and then we go to the left, meaning that we choose, let's say, r equal to minus, r equal to 3, then we have r, extract that. Let's take like x equal to 3, then r equals to 1, x equal to 2, r equal to 2, x equal to 0, r equal to 4. And if we take x equal to minus 100, r is equal to 104, and so on. So as the value of x decreases, so when we choose the value of x decrease like this, from the right to the left, from 4 to minus infinity, the value of r is from 0 going increases to positive infinity. In this case, we see this guy, and this guy looks the same, right? We just change x into r. So we have the domain r is from 0 to infinity, meaning that the range of the variable y is also from 0 to infinity. Understood? Any questions? Any question?
I think no, sir.
Now, the final example. Why the domain is only from -1 to 1 in this case? So the same thing happened, right? So we want, we have y equals to square root of 1 minus x squared. What we want is what is inside the square root is greater or equal to 0. So meaning that we have 1 minus x squared greater or equal to 0. If we factorize it, we have 1 minus x, 1 plus x greater or equal to 0. And if we draw the line, like in the morning session, we have this -1, 1, and since this is this contains equal part, then meaning that we have filled circle. Now we test with 0. If we put 0, the value here is positive, and so the rest is negative. That's why we have that this is the solution. That's why the domain of this is x in -1 to 1. As for the range, we have only from 0 to 1, because the value of 1 minus x squared as x move from -1 to 1 can only be from 0 to 1. So the square root of numbers between 0 to 1 is also between 0 to 1. Those are the example of functions. Now the challenge. What is the domain and range of this function? Can anyone tell me what is the domain of this? What is the domain of x in this case? What is the domain of x? So fx equals to square root of 5x plus 10.
-2, -2 to positive infinite.
Yes, yeah, that's correct. So what we need is the same, right? So we have f of x is equal to square root of 5x plus 10, meaning that we need 5x plus 10 greater or equal to 0, meaning that we have x is greater or equal to -2. This is the domain. What is the range of this function?
Zero to positive infinite.
Correct. So the range for this function is also from 0 to positive infinite. So this is still easy challenge. The next challenge is this. What is the domain and range of this function? What is the domain?
+2 to negative infinite.
Okay. Any other answer? let's see, we have f of t equals to 4 over 3 minus t. So what cannot happen in this function? What is the thing that should not happen in this function?
Penyebutnya nggak boleh 0.
Yes. So basically, 3 minus t cannot be equal to 0, meaning that t cannot be equal to 3. Okay. So the domain is now from negative infinite until 3, but 3 is not included, union 3 to positive infinite. Or we can also write it like this. This is equals to set of real numbers minus 3. So set of real numbers except 3. Or this is also the way to write the domain. So you can when you are doing exam or quiz or homeworks, you can choose whatever way of writing the solution as you like. Which one that you understand the most, that's okay for me. Okay, any question? Okay, in this case, what is the range of this function? What is the range of this function? F of t equals to 4 over 3 minus t. What is the range? So basically the range is the same as this 1 over x. Why? Because, let's see. We have f of t equals to 4 over 3 minus t. We can see it like this, 1 over 3 minus t over 4. So let's say x equals to 3 minus t over 4. Then we have that it will look similar to 1 over x. So in this case, when the range of x is when the domain of x is everything but 0, okay. When the domain of t is everything but 3, we have that x is everything but 0. As long as t is not equal to 3, when t equal to 3, we have x equal to 0, meaning that we can transform this domain into something like this. And we know that for this function, we have that the range is here. Everything except 0. Any question? Any question? No? Oh, we talk about the graph of functions. What is graph of functions? Formally, it is defined like this. So the graph of a function is actually a set of points, a set of pair of points, x comma fx, where x is in the domain of f. And when we have all sets of points, we can draw the graph over Cartesian plane. That's basically the formal definition. But I think it is not hard to understand because you already know how to draw the graph of a function from your high school period. So now we just go straight to the example. The first example is we are asked to graph the function of y equals to x squared over the interval -2 to 2. How to draw it? These are the steps that we can take. First, we make a table of xy pairs that satisfy the equation y equals to x squared. I mean, it should satisfy the equation over this interval. So meaning that first we have, okay, let's write this x in -2 up to 2. Now we need to make a table, of xy pairs that satisfy this equation. So let's try to list x and y equals to x squared. So we will have a table that looks like this. Now let's try to take a point x equal to -2. What is the value of y in this case? When x equal to -2, the value of y is equal to x squared, meaning that -2 squared, what is the value of -2 squared? Hello?
4.
4. Yeah. 4, let's say we take a value x equal to -1, then what is the
1.
value of
1.
1? And then 0, 0. Let's say we also take 1,
1.
1, and 2,
4.
4. Is the first step. Now the second step is plot the points x comma y whose coordinates appear in the table. So we make a Cartesian plane like this. This is x and this is y, and we take point x 0, x equal to 1, -1, x equal to -2, here x equal to 1, x equal to 2, and then here is y equal to 1, 2, 3, 4. So we plot the points. We have this point, And now we have also this point. And after that, we go to the next step. The next step is that we draw a smooth curve through the plotted points. So we draw a smooth curve so that you can see something good. Because my drawing is not that good, I will just use programming language to do that. Where is the plot? Let's say we have f of x equals to x squared equals to x squared. Okay, now the first step is to plot sorry, let me check what to do. Yeah, plot scatter, and here x list comma y. Let me see if this can work. Please vote. Okay, so we have a plot like this. These are the points. Now draw a smooth curve through the plotted points. I'm showing you two choice of plots. Now, which one is the correct plot for y equals to x squared? The green one or the red one? The green one or the red one?
The red one.
The red one. Okay, any other answer? Okay, the answer is correct. So basically what I want to show you here is that when we have only the points like this, then we add, then we just simply connect the points. We will have something that looks like this. This is not smooth because you see that there is like a there is an angle well, there are angles. There is an angle between two lines, which is not quite smooth, and the picture of the plot should look like this. So we cannot simply connect the points, but what we need to do is basically we collect more points, like let's say -2. We need to collect more points and then we can connect them. So the more points we have, the smoother our graph looks like. That's basically the idea. And we need to remember that the function f can only have one value of fx for each x in its domain. Why? Let's say if we want to plot different things, so now the function is not x squared but square root of x, then we have something else. Oh, square root of x, the x cannot be negative, meaning that let's start from 0. We have like this. Okay. Or here is from 0 to. So when we choose a function, we can only have one value of f of x for each x. But what I want to ask you is that do you remember if we have fx equal to square root of x in your high school? Let's say square root of 4. What is square root of 4 in your high school?
2.
2. Can it be -2? 2 or -2?
-2, yeah.
Yeah. So we can have two values of square root of 4, right? But in a function, we cannot have this. So basically in a function, when we have the function fx equal to square root of x, then we only take the positive value. So the plot is only the top one, not the bottom one. Up to this point, any question? Any question? If not, then now try to graph this piecewise function. For this, let me use again this code. So piecewise function is that f of x, if x is less than 0, and no, x less than 0, then the value is minus x. If not, then we ask another question, whether x is greater than 1. If yes, then the value is 1. If not, meaning that the x is between 0 and 1, then we have x squared. So the process is the same. We make a table let's say here x is -2, -1, 0, 1, and 2. And then we plot the graph of the function. And then we have this plot. So in this case, which one is the correct plot? The orange one or the blue one? Remember that between 0 and 1, the value of fx is x squared. So the correct one is the dashed line or the blue line. Which one? Anyone knows?
Sir, I
Yeah.
think it's a blue one maybe.
Why?
Can you back to the question? Because apa ya namanya? Dari 0 kurang dari ini kan yang tengah ya, Pak?
Ya.
Karena kalau di grafiknya itu apa sih smooth kayak yang tadi loh, Pak?
Yeah. Okay. I understand what you mean. So basically what he says, what's that? Russia.
Yes, sir.
Okay, what Russia means that when x is in between 0 and 1, we have the function of f of x is x squared. And the plot of x squared is definitely not a straight line. So that's why the correct plot is, in this case, the blue line. Let's try to do the same thing. We make the x to be like this, -2, and then we take step 0, 1 up to 2. We plot it, it should look like this. So if we make the 0.5, so the plot will look like this. And if we take more points, 0.1 more points, then the plot will be smoother, will be more smooth. If we make the points, if we put more points, then the plot will getting very close to the actual plot. Like that. Okay. Anyone? So any question from this? Any questions? Getting more confused or getting enlightened with these materials?
Sir,
Yes.
I want to ask the example. Yeah.
This one.
Yeah, that one. Is there only we need to draw one graphic or only one or three graphic each one?
Or this one? So it depends.
Yeah.
It depends. The answer is it depends. When we are asked to draw this graph over the interval from -2 to 2, then we have to draw it from x equal to -2 up to x equal to 2. But if we change the interval, let's say we plot only from 0.5 up to 2, you will have different, the start is 0.5, top is 2. So let's change it like this. Start. Also in this plot, we change it to start and stop. if we are asked to draw only from 0.5 to 2, then the plot will be different. The plot will look like this, because we only need to plot it from 0.5 to 2. Let's say if we change the plot, if the interval of plotting is only from, let's say, 0.1 to 0.8, then the plot will change again. Plot will change again like this. So, plot will change again like this. So in this case, since if we are asked to only plot from 0.1 to 0.8, meaning that we only need to plot this part, this middle part. So it depends on the questions, basically. Is that clear?
Yeah, okay. Thank you, sir.
Okay. Now this is the classroom challenge. Try to graph this equation and explain why it is not graph of function of x. Well, yesterday I tried to plot it with implicit equations, but it turns out that there is a problem with my library. So, oh no, good. Okay. Let's hope that this, we can see the plot. Otherwise, it is hard to explain this. Oh man. Julia, plot implicit equation. Oh, maybe I need to put this. No. Ooh. Okay, so absolute of x plus y. equals to f equals to 1. Hope that it works. Otherwise, it is hard to explain this one. I don't know. Then let me try to explain it with my hand like this. So the equation is like this: x plus y equals to 1. Then if we put if we choose x, let's say x equal to 0, what is the value of y in this case?
is 0.
So if x is
Not
equal to 0, then y is equal to 1. But when we have x equal to 0, y can also be minus 1. Correct? Correct?
Correct, sir.
yes.
Yeah. Now, if we have 1, then
Two.
y equals to
2 0.
0. If x equal to minus 1, y equals to
0.
2
0.
0.
Yeah. So now the answer why it is not graph of function of x. So meaning that we want to say that y is a function of x, but it cannot be a function of x because here for one value of x, we have two different values of y. This is not allowed in a function. Let's consider this as y of x, right? But what happens if we have two different value of x, but we have the same value for y? This one is okay or allowed. So since in this case we have this one value of x resulting in two values of y, meaning that this is not a function of x. Any questions? Okay, I hope that you don't ask because you understand, not because you are confused. Okay. This is easy plot. We can try immediately here. Let's say f of x. Is equal to, okay, let's say 0, x. This happened, then the value is x. Otherwise, the value is okay. Otherwise, we check again if 1x correct, then 2 minus x. If not, then let's say 0. Now we try to plot it. X from 0 to 2. 0, let's take 0.1 to 2. Or let's just plot it. Plot f from 0 to 2. So we will have a triangle plot like this for this challenge, for this question. So you can try it by yourself later at home, but the result should be like this. So before 1, it is increasing, just a straight line, and after 1, it is decreasing, again, just a straight line. Now, different kind of question. Find the formula of the following graph. For this graph, so we have the graph, this is 2, this is 2, this is 1, this is 5, this is x, this is y. So for this graph, as we can see here, we have two straight lines. So basically, we go back to the basic of straight lines. The formula for straight line is y equals to mx plus c. Particularly for this graph, we will have y of x is equal to something like this. It should be minus x plus 2 when x is from 0 to 2, but but 0 is not included. And then when x is from 2 to 5, we should have I think it is minus x over 3 plus 5 over 3. Well, you can check it at home whether my formula is correct, but I think this is the answer for this graph. Any questions up to this point? If not, then we are coming to the last two parts for this materials. First is increasing and decreasing functions. What is increasing functions? Let's say f is a function defined on this interval I. And then we take 2 points in this interval, say x1 and x2, and we chose x1 to be less than x2, then how to check if f is increasing or decreasing on this interval? To check it, we simply check if whenever we change the value of x1 and x2, this relation remains the same. So if x1 is less than x2, but the and the function and the value of f of x1 is less than the value of f of x2, then the function is called increasing function on this interval. But if the other way around, then the function is said to be decreasing. What is important here is that these two things, these things must be satisfied for every possible pair of x1 and x2 in the interval I, with x1 less than x2. And the interval I can be finite, let's say from 0 to 1 or from -2 to 2 or whatever, that is called finite. Or the interval can also be infinite, let's say from 0 to positive infinity, or from negative infinity to, let's say, -5, or from negative infinity to positive infinity, and so on and so forth. This is the definition, and for the example, we have this. We go back to the previous piecewise function. In this case, we have that the function fx is decreasing on the interval -infinity up to 0. So if we pick the interval only from -infinity to 0, we know that the piecewise function f here is decreasing. So -x is a decreasing function, and this function is increasing on this interval because, okay, let's just look at the plot. From -1 to we see here that on the left side, so before 0, the function is always decreasing, and between 0 and 1, the value of the function is always increasing. That in that case, we can say that the function in this interval from 0 to 1 is an increasing function. But after that, we have that the function is neither increasing nor decreasing. So it's just flat. So it is not increasing and also not decreasing. Another example that I want to show you is, let's say we have a plot that looks like, where's my pen? There. If we have a plot like this over this interval, what to say? Do we say that the function is increasing or decreasing, or both increasing and decreasing, or neither increasing nor increasing in this case? What is the correct answer?
I think it's both, sir.
Okay, that is possible, but in this case, based on the formal definition of increasing or decreasing function, in this case, we cannot say that this function is increasing, and we also cannot say that this function is decreasing. That's why in this case, this function is neither increasing nor decreasing. Understood?
Understood, sir.
So it is increasing if for the whole interval, we have an increasing trend. But it is decreasing if for the whole interval, the function is decreasing. Otherwise, it is neither increasing nor decreasing. Okay. Now, the challenge is we are asked to graph this function and determine the interval for which the function is increasing and the interval for which the function is decreasing. Well, I happen to have the plot here, actually, this one. So this is the plot of x cubed over 8. So we see that for the whole interval over real numbers, the function is always increasing. So we say that this is an increasing function. You can check it later at home, but I want to jump to the next function. Before that, I will let you ask something that you may not understand. So any questions? No? Okay. Next part of this first part is even functions and odd functions and their relation to symmetry. What is even function? Let's say we have a function y equals to f of x. Then y equals to f of x is an even function of x if we have this, if f of minus x equals to f of x. We have y equals to f of x called an odd function of x if f of minus x equals to minus of fx. Okay, what happened if neither these rules are true for our function? Then we cannot say anything. In that case, we say that the function is neither even nor odd function. So for even function, we have this definition. Definition number 1. For odd function, we have the next one. And it is important to know that it should work on for every, it should be satisfied for every x in the function domain. And another note is that important to know that even and odd function is highly related to symmetry. Why? Because the graph of an even function is always symmetric about the y-axis, and the graph of odd function is always symmetric about the origin or the zero coordinate. For example, let's take f of x equals to x squared. This is called an even function because if we put f of minus x, meaning that minus x squared, we have that minus x squared equals to x squared. That's why we have in this case even function. And if we check the plot, let's plot it again here. Okay. Plot fx squared. We have this plot, and you see that here is the y-axis where x is equal to 0. Then you see that the plot is symmetric about the y-axis. For the next example, f of x equals to x squared plus 1. This one is also even function because of this. So we can simply check it like this. And it is also symmetric about the y-axis. Let's say we change it to x squared plus 1. We plot it again. We have this. It remains symmetric. What happened with f of x equals to x? This is called an odd function. Why? Because f of minus x equals to minus of fx. That's why this is called an odd function, and it is actually symmetric about the origin. So let's say we have x plotted. It looks like this. The origin is the point here. So plot center mm, 0. Oh no, it should be like this. Okay, so the origin is this point 0.0, and you see that the graph on that side is symmetric to the graph on this side, on the third quadrant. That's why you can see that it is symmetric about the origin. Up to this point, any questions? Any question? Just ask if you don't understand. Please ask. If you don't ask, I don't know whether you understand or not. Okay, so what happened if we have f of x equals to x plus 1? This guy, if you see, the first one is even function, and if we shift it by 1, we plus 1, we still have an even function. But for this case, we don't have an odd function. Even though f of x equal to x is an odd function, f of x equal to x plus 1 is not an odd function, and it is also not an even function, so it is neither even nor odd function. Why? Actually, it is simply because if we plot it like this, so we have that it is not symmetric about the origin. So there is a slight movement, or the slight shifting. So we cannot reflect it about the origin anymore. That's why in this case, it is neither even nor odd function. This one we already explained it. What about this one? This one is even function, odd function, or neither. I give you 1 minute. Whoever finish first can open their mic and say whether this function is even, odd, or neither. So 1 minute starts now.
I'm sorry, sir. I want to ask actually.
Yes.
Can you move to the before slide? Yeah. Okay. So I want to wait. Calculus. Can you explain again, sir? The difference of even function and odd function.
So even function if this is true, odd function if this is true. So basically, let's try to paint here. So even function, we have f of x, f of minus x should be equal to f of x. Example, we have f of x equals to x squared, or let's take x power 4. Then to check whether this is even or odd, let's take f of minus x. We have here minus x power 4. Then in this case, we have minus 1 power 4 times x power 4, which is equal to x power 4 because minus 1 power 4 is 1. Then here is equals to f of x. So in this case, we have this relation. F of minus x is equal to f of x. Then we have even function. What about odd function? Odd function. Odd function is if we have f of minus x is equals to minus of f x. Example. F of x is equal to x power 5. Then we check f of minus x is equals to minus x power 5, which means that we have minus 1 power 5 times x power 5, which is minus x power 5, which is minus of f of x. In this case, since we have this relation, f of minus x equals to minus of fx, then we have f of x equals to x power 5 to be an odd function. Is it clear?
Okay, it's clear, sir. Thank you, sir.
What about this function? Is it even, odd, or neither?
Sir,
Yeah.
I'm sorry if I'm wrong. I think it's even.
Okay. Any other answer? Let's check. Let's check whether this is an even function or not. G of x is equal to x power 3 plus x. Then how to check it? We just need to check whether g of minus x equal to something that we have. G of minus x is equal to minus x cubed plus minus. Then in this case, we have minus 1 cube x cubed plus minus 1 times x, which is equals to minus x cubed plus x. Why? Because this guy is equals to minus 1. So we have minus 1 and minus 1. We have minus 1 here and minus 1 here. We can factorize it. We can take out the minus 1. So we have now minus of x cubed plus x. Then this is equals to minus g of x. So in this case, g of x equals to x cubed plus x is even or odd or neither. What is the answer?
Odd.
Odd function. Correct. So this is an odd function. That is the end of the first part of this session. And there are like 9 challenges here that you can work with. You can try at home. Please make sure to try it at home, and we move to the next part. In this last 14 minutes of this session, I will try to explain as far as possible in this whatever materials in these slides. But if I cannot finish this slide, then we will learn about it in our next meeting. So next meeting we will continue from where we'll talk here. So the materials here is about combining function, shifting, and scaling graphs. The first part is the harder part. The next part is not is quite easy. So the next part can be finished very quickly, maybe next week. But for the first part, we learn about some different product quotients and then composite functions, which actually you have learned in high school. First, the definition of these operations. So if we have f and g to be our functions, so let's say f and g are functions, then for every x that belongs to the domains of both f and g, that is x must be in domain f and also in the domain g, then we can define this addition, summation, difference, and multiplication or product by this formula. So basically, what happened in the left-hand side of the equality is here we sum the function, but on the right-hand side, we sum the value of the function. And for the second one, here we take the difference of the function, and on the right-hand side, we take the difference of the value of each function, and so on. As for the quotients or division, then we have different, slightly different rules that needs to be satisfied. So let's say x is in the domain of f intersect with the domain of g. So x is in the domain of f, also in the domain of g, but here g of x cannot be 0, because if g of x is 0, then this operation is undefined. So this cannot happen. So we add a condition that g of x cannot be 0. Then if g of x is not 0, then we have this operation, basically the same thing as the one above. And if we multiply a function by some real number c, then we have this operation. Let's take a look at the example. So let's say we have f of x equals to square root of x, g of x equal to square root of 1 minus x. In this case, the domain of f of x is from 0 to infinity. The domain of g of x is from minus infinity to 1. Remember the explanation about the domain of a function? And in this case, the point x that common to both domain, I mean, the x that present in this interval also in this interval are only the point x in this interval from 0 to 1. Agreed? Any question before I continue with the table? Any question? Understood?
Yes, sir.
I think not, sir.
Okay, so it's quite easy, right? Then in this case, we have the function f plus g to be this, with the domain now not this big, also not this big, because we have f plus g. It must satisfy this. So the domain is now only from 0 to 1. Also, f minus g, we have this new expression, square root of x minus square root of 1 minus x. The domain is the same from 0 to 1. G of x, we have different expression. The domain is still the same, f times g. we have another expression, and the domain remains the same. But what happened with the quotients? So f per g. Now, remember that if we have quotient like this or division, then the denominator cannot be 0, meaning that the value of x that makes, in this case, the value of x that makes g 0 cannot be included in the domain. So we see that g of x equal to 0 if x is equal to 1, right? Because if x equal to 1, we have square root of 1 minus 1, meaning that we have g of 1 equal to 0. That's why in this case, 1 is excluded from the domain. The same thing happened with g divided by f. In this case, f cannot be 0, meaning that whatever value of x that makes f equal to 0 must be excluded in the domain, like this. Because if x is equal to 0, then f of x equal to 0, then we don't have, we cannot define the value of this function. Any questions up to this point? This should be simple, right? Because I think you already learned about it in high school. But let's take a look at this example. So this one should be easy. We can, do we need to, do you need me to solve this, or you can try this one at home by yourself? Up to you. You want me to solve this, or you'll try it by yourself later? This one is easy, right?
Yeah, maybe sir can explain before we make it by ourselves the next number.
Okay. I will not explain this one, but I will try to explain this one. Why? Because I think this must be harder because of the quotient. Let's say we have, okay. We have f of x equals to 2, meaning that the domain of f is, what is the domain of f in this case? What is the domain of f? G of x equals to x squared plus 1. What is the domain of G? So first, what is the domain of f? What is the domain of f? Anyone knows? F of x equals to 2. What is the domain of f? What is the domain of f in this case? Okay, whatever value of x, the result remains the same, right? So in this case, the domain can be anything. The domain is from minus infinity up to positive infinity. Agreed? Hello?
Yes, sir.
And for the second one, the domain, what is the domain for the second one? I think it should be this one. Do you agree? Do you agree that the domain of the function g is from minus infinity to positive infinity? Okay, I think you agree. Okay, now let's check about this f over g. F over g, meaning that we have 2 over x squared plus 1. So in this case, the domain of f over g. What is the domain of f over g? Okay, my question is, can the denominator be equal to 0 with this domain? So let's check the range of this function. The range of f is obvious because f is constant and the constant is equal to 2. So the range of f is 2. What is the range of g? Let me give you a hint. Here, from something to positive infinity, what is the value of this missing part? 0?
Yeah, 0.
Okay, let's check.
Minus infinite, maybe.
Okay, let's check.
1 maybe.
The correct answer is the last answer, 1. Why? Because we have x squared. X squared cannot be negative. So the lowest value of x squared is 0. And we have everything shifted up by 1, meaning that the value is shifted up. Then the lowest value is now 1. So the range of g is from 1 to infinity. And since g cannot be 0 at any time, so for any x, the value of g cannot be 0, the domain of f over g still the same, negative infinity up to infinity. But the range of f over g is something different. The range of f over g is from 0 to 2. 0 is not included because the value cannot be 0. So let's see if x is equal to 1. Oh, sorry, from 0 to 1. If x is equal to 1, no, from 0 to 2. That's correct. So if x is equal to 0, then x squared plus 1 is equal to 1. Then we have 2 over 1, 2. When x is getting bigger and bigger, the value of the bottom part is getting closer to infinity. So 2 divided by something closer to infinity, the value will be very, very, very close to 0. That's why the range is from 0 to 2. Now, how about g over f? Here we have x squared plus 1 over 2. In this case, the domain of g over f stays the same, minus infinity to infinity. But the range of g over f is not the same. So what is the range? The range is from, okay, since the time is up, I will just tell you what is the range. The range is from half to infinity. So that's all for today. Next Friday, we will continue from composite functions before continuing to the next material. Before I close the session, any questions? If you have any questions, just ask. Any question?
Pak.
Ya.
Apakah yang terakhir tadi itu range-nya itu tetap setengah, nggak 1?
Okay. Why not 1? Let's try to put x equal to 0. Then the value of g over f is half, right?
Oh iya benar Pak, setengah.
Yeah. So basically, we just need to divide the range of g here by 2. That's why we have it. We have it started from. We have it start from half instead of 1. Any other question?
Sir,
Ya.
untuk soal yang tadi, Sir, yang terakhir, pertanyaan yang sama, Sir, sama Rachel. Itu kenapa harus infinity? Kenapa bukan 0?
Which one? This one?
Yang range, yang, iya. Kenapa infinity?
From half to infinity, you mean?
Itu
Oke.
Yeah, it is from half to infinity because as x increases from 0, x increases, then the value of the upper for the value of the numerator is getting closer to infinity, is going to infinity. That's why even if we divide it by 2, the value remains infinity. That's why. Any other question? Is it clear?
Not.
Okay. Then let's end this session now. Let's
I'm
meet.
sorry,
Yeah,
sir.
Jason.
Can I have your contact?
Okay. You can contact me via Microsoft Teams. So you can just chat me in Microsoft Teams. Here, you can just click chat and create a new chat. Find my name. Then say anything to me.
I'm sorry, sir, but saya masih kurang tahu, sir. Untuk jam kantor itu dari jam berapa sampai jam berapa ya?
Okay, you can consider my office hour to be from 9 to 5. 9 in the morning until 5 in the afternoon. But in my case, in my class, you can ask me anytime, and but I will only answer during working hours. However, if it is something that is quite important, or if I am quite free at that time, I will try to answer as fast as possible. So you can ask me anytime.
Okay, thank you, sir.
Any more question? Ya, Vega.
Sir, untuk challenge-nya itu apakah dikumpulkan minggu depan?
No, the challenge is for yourself. It's not to be submitted. But if you want to be successful in this class, you have to try it by yourself at home. It is not a homework, it's just a challenge.
Okay, thank you, sir.
Any more question? Okay, actually, there will be homework, but not from this slide. The homework will be delivered by the coordinator of this course. So I'm just teaching you here. I'm not the coordinator, but the coordinator will give you some maybe tutorial class. I mean, there will be tutorial class, I think. And in that tutorial class, there will be some tasks that you need to do. Actually, those tasks will be considered as your homework. So that's not the challenge in this slide, but there will be another session with the assistant, with the teaching assistant. Is it clear?
Yes, sir. It's clear.
Okay. Then let me end this session now. See you later next week on Friday morning. Good afternoon and assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you,
Thank
sir.
you,
Thank you,
sir.
sir.